Okay, so this PowerPoint will go over some basic information about research and statistics. A lot of this you will cover in more detail in the fall, but I wanted to go over some of it because you're reading research articles now. Here's some of the objectives. We're not going to go through all these. I'm going to highlight some things that I think are important. Number one, we talked about variables. And variables are things, are attributes, are various categories that are controlled or defined during the research process, okay? And so you can have what we call independent variables, which are variables that you can either control in a study by only using people of certain age, or you can manipulate the signal to noise ratio. So those are independent variables, and those things don't vary. You control those. Then the dependent variables are outcome variables. So if you do a study where you say we're going to use two signal to noise ratios, +5 and -5, and we're going to measure the word recognition score. Well, your word recognition score is your dependent, your signal to noise ratio is your independent, because you're manipulating those. Then we talked about confounding variables, are variables that you don't know of and you can't control, or you either can't control or you don't know about. Now, levels of variables, nominal, ordinal, interval, and ratio. I'm assuming at some point in undergrad you talked about that. But all studies have to have one independent and one dependent variable. And you can manipulate those independent variables experimentally, or you can observe. You can control for those and include people of only certain ages or sex or what have you. And that's how you control that. Experimental research is when you manipulate something. So if you think back to the article we read with my study, we manipulated the speech signals, right? The sex identification task we did, we changed how we used that vocoder to change the variable, to change the signal, and that's the manipulation of a variable. So that was an experimental project. Now, correlational research is a little different, and I think we'll have a discussion about this in class, but correlational research lacks experimental manipulation. So you don't actually manipulate any variables in correlational research, which limits your ability to say, to provide a cause and effect relationship. Okay, and we'll talk a little bit more about this in class, but when you don't manipulate a variable, you cannot, when you don't do a true experiment, it's impossible to draw these cause-effect relationships. You can only say that this change was associated with X, okay? And you see this a lot in the media, to be honest. You see a lot of people using correlational research to then say something causes something, okay? And we'll talk more about that. Hypotheses, right? You saw in my study we had hypotheses that we thought would be, we thought we would find. We expected certain outcomes, and guess what? We didn't find that. So we had to go back and say, well, contrary to what we thought, we didn't find this, okay? And your studies need to be sensitive enough to capture those differences. So if you remember what I mentioned in my study, maybe the manipulations we did for the gender/sex identification was not sensitive enough to these differences to actually capture that between the two groups. So that's something that is important. We'll talk about hypotheses testing. That's not something you need now. There's always error in research. I think the one thing that I want you all to understand at this point is that there's no study is perfect, and there is always error in research, okay? Type 1 error occurs when you say something, you say there's a difference between groups, but there's really not. Type 2 occurs when there is a difference between groups, like in my study, the musicians and non-musicians, but you don't find that difference, okay? So those are different types of error, not something we need to go into a lot right now, but there is the thing to remember at this point before you take the evidence-based class in the fall is that there's always error in research. Study designs, I'm not concerned about that right now. Sampling. So one thing that's very important when you do research is, if you recall when I said you were going to measure satisfaction with the food in the dining hall at WVU, and you only stood outside at 8 o'clock in the morning and asked people as they come out, right? We talked about the limitations of that. You would only get certain people, most likely. You would only sample how they felt about breakfast. And so sampling is a really important characteristic of research. You want it to be as randomized as possible. So you would want to show up at the dining hall different times, maybe survey the second or third person out, every second or third person out. So you want to randomize your sampling, okay? That's a really important part of research. Now, those scales that we talked about, nominal, ordinal, interval, and ratio, this I think you should brush up on and really be familiar with. Nominal is a categorical, male, female, with no order. Ordinal is categorical but has some order, and there you can see freshman, sophomore, junior, senior. Interval, you can define the distance between, let's say, the number 1, 2, 3, and 4. The distance between these are kind of messy, but interval scale, you can define the distance between all of the values, and it's the same. But it doesn't have an absolute zero. So if you recall, an absolute zero is like an absence of an attribute. So temperature can go negative, so you can have minus 10 degrees. So temperature is an interval scale. Ratio is the same as interval, but it has an absolute zero, meaning that zero means an absence of sound, okay? Or an absence of whatever attribute you're looking at. The bell curve, the normal distribution, I'm sure you have seen this at some point. You have, here, well, I'll use this one. Here you have the mean value, 1 standard deviation above the mean, 2, 3, and 4 standard deviations above, and then 1 standard deviation below, 2, 3, and 4. And you can see how much, so if you said, okay, one of you scored at 1 standard deviation above the mean, that would be right here. Here you would have cumulative percentages. You would have scored better than 84% of the population. Okay, so if you haven't had an undergraduate stats course, I think it would be important, and we can chat about it again, this normal distribution, because that's really, when we do research, we need our data to come from a fairly normal distribution like this. It can't be something that's very skewed and has all of its values up here or down here. Does that make sense? Z-scores are essentially a way to standardize these normal distributions, and they correlate highly with, there's your Z-scores. One Z-score, a Z-score of 1, 2 is very similar to standard deviation, as you'll notice. They're the same values. So when you went into the doctor's office, when your parents took you into the doctor's office when you were a child, and the doctor said, well, your kiddo's at the 85th percentile for height, you were 1 Z-score. Your Z-score was 1 or 1 standard deviation above the mean. So these Z-scores allow you to take a value and compare it to the standard distribution, the normal distribution, and come up with a Z value. Okay. Descriptive statistics, these are the statistics that we use to describe data. Okay, I think that's the important point to understand. Mean, median, mode, standard deviation, range, all of those I'm sure at some point you've talked about. These describe the distribution of data. These do not infer anything. And so we have, I'm going to get my pen here. Excuse me. So when we say descriptive statistics, which is different than inferential statistics, which I'll mention, but essentially they describe your data. They don't tell you much other than where your data point falls among other data compared to other data in that set. Now, inferential statistics are a little different. So if you remember the other day when we talked about ANOVA, we talked about t-test. those types of things. Those are what we call inferential statistics, and they basically help to infer from our sample data to the population. Okay, so if you think of the study that I did with the student, we inferred from our sample of 14 musicians and 14 non-musicians that musicians had better temporal processing skills on the gaps in noise test, right? So we're saying that based on our sample data. We didn't test every musician in the entire world, right? So we're taking our data and we're inferring using the ANOVA, using the other tests that we used, to infer something about the performance of musicians versus non-musicians. So again, descriptive statistics describe data. Inferential statistics infer something from your sample to the population. I'm not going to talk about the parametric model. That's not really important right now. But inferential techniques, these are things you're going to run into in your reading of articles. Now, we talk about our p-values, right? The probability that our result is due to what we manipulated or due to random chance. And as a scientific community, we have decided that we're okay with about 5% error. Okay, that's essentially, so p less than 0.05 means your probability is less than 0.05 that it was due to just random, your results were just due to random error. Okay, some people might use and be a little more stringent and use 0.01, but that's what probability testing is. Now, t-testing, we talked about that. When you want to determine if your results are different than another group and you have two groups or two conditions, that's the important thing to talk about with t-test. It gives you a t-score down here, but don't worry about that. A t-test is an inferential test because it goes beyond just describing the data like this. Okay, the t-test helps you infer something. The ANOVA, the analysis of variance, we talked about that, where we basically, hold on, I lost my slide, where we have 3 or more conditions or groups and we need to test whether there are significant differences between the groups. Okay, correlation analysis, this is something that, again, when we do, it's an inferential technique, but it doesn't it doesn't always give you a cause-effect type outcome. Okay. Now, if you design your study correctly, yes, it can, but in many cases, correlational analysis does not. You have to really design your study the correct way, and we're not going to get into too much of that. But what I wanted to show you is correlation, positive, right? So your data suggests that as this one goes up, this variable, whatever that x variable is, the y goes up. This one's the opposite. As your variable goes up, y goes down. And then this one, there's no relationship. You can't really draw a line through that to show a relationship. So positive correlation, negative correlation. Here you could draw lines through it. It's the same thing, and there's no correlation. This gives you some values, like a perfect correlation. Positive is 1, perfect is negative. Not a perfect correlation, but 0.6, and we'll talk more about those values at some point. But just for now, this is correlation. And then regression analysis is similar, but it allows you to predict different things. And I want to go through this. So here's one that I like to show. So if you have the weight of a car and then miles per gallon, right? As the weight of the car gets heavier, going from 2,000 to 5,000, your miles per gallon goes down. That would be a negative correlation. And we'll talk more about that. This is a way to kind of explain that. I'll explain this in class. We'll go over this real quick, but I thought this was funny. Basically, this was in the early days of social media, but looking at the relationship between variables, in this case, the humorous, narcissism, ADHD, and stalking, but and how these social media platforms kind of have this relationship between the multiple attributes, which we'll talk about. Okay, so that's good. We will chat about more on next week.